Now we are going to see the focal property of an ellipse, which is theorem 5.5 given in your book. The sum of the focal distances of any point on the ellipse is equal to the length of the major axis. That is the sum of the focal distances. So focal distances means the distance from the focus to that point. So here f1p is the focal distance and f2p is the another focal distance. So according to this theorem, we have to prove the sum of the focal distances f1p plus f2p is equal to the length of the major axis, which is nothing but 2a. So we have to prove f1p plus f2p equal to 2a. First let us consider the point P of x comma y on the ellipse. Now we have taken the major axis is along x-axis. So consider the point on the ellipse. Now for the proof convenient, I am going to draw PK perpendicular to x-axis. PK perpendicular to x-axis. Here I have used the letter K. You can use any other letters also. So draw PK perpendicular to x-axis. Next, by the definition of conic. So conic definition is the distance from the fixed point and the distance from the fixed straight line. இந்த ரெண்டு டிஸ்டன்ஸுக்குள்ள ரேஷியோ தான் eccentricity அப்படினு சொல்றோம் இல்லையா. So f1p, the distance from the fixed point is f1p and the distance from the fixed straight line is pm. That is f1p by pm is equal to eccentricity. So likewise the another one focus we are having. So f2p, distance from the fixed point, f2p by the distance from the fixed straight line pm dash, the another directress d dash. So the another distance, fixed distance from the fixed point is pm dash, that is equal to e. Now f1p can be written as e into pm. Bring this pm to the right hand side. Now e into, instead of pm, so see the diagram, the distance pm is equal to kd, isn't it? The distance pm is equal to kd. So instead of pm I am writing kd. So e into, now this kd, the distance kd can be written as cd minus ck, isn't it? kd can be written as cd minus ck. So cd minus ck. E into, what is CD? The distance between the center and the directrix. The distance between the center and the directrix is taken as A by E. Already we know that, isn't it? In an ellipse, the distance between the center and the directrix is A by E minus CK. Now CK, the horizontal distance CK, what we have taken is X, isn't it? The distance CK is X. So instead of ck, I am writing x. Now bring this e to the inside. So e get cancelled, a minus ex. So the focal distance f1p, what we have calculated is a minus ex. Now we have to calculate the another focal distance f2p. That is f2p equal to e into pm dash. So E into this pm dash, see the diagram, this pm dash can be splitted as ck. Pm dash can be splitted as ck plus cd dash, isn't it? Pm dash, this distance, which is equal to kd dash. That is kd dash can be splitted as kc plus cd dash. So first you have write kd dash and then split this kd dash as kc plus cd dash. Kc plus cd dash. So e into kc. So kc or ck, both are same. So what we have taken, ck or kc is the horizontal distance x, and cd dash represents the distance between the center and the another directrix. So which is nothing but A by E. Now after simplifying we get EX plus and EE get cancelled plus A. So the another focal distance F2P is calculated as EX plus A. Now let us find the sum of the focal distances F1P plus F2P. It is A minus EX plus EX plus A, which is equal to 2A. Now 2A represents the length of the major axis. In an ellipse, the length of the major axis is 2A. So instead of 2A, I am writing the length of the major axis. Now the result, what we have proved, F1P plus F2P equal to 2A. We have completed the proof. That's all.